G'day. Sometimes people ask, what should I be looking for in a machine tool? And usually they're talking about, should they buy a second-hand one or a new one? Now, I'm a fan of second-hand machines because I believe that they are probably built a little bit more solidly. They've got wear in them, of course, but you do learn a lot by taking a machine apart and fixing it up, certainly much more than you would if you just buy one off the shelf and expect it to plug and play. Now, a lot of the smaller lathes and mills that are sold to hobbyists are precisely that. They're hobbyist machines. They're there to, they're built to a price rather than built to a specification, and so you need to be careful with some of those. That's not to say you can't do great work on those, but you must be aware that there are some limitations. You may have to overhaul them. I hear stories about people who first thing they do is drain the oil out of the gearbox, take all the sand out of the gearbox, fill it with good oil, replace some of the seals and all that sort of thing just to get the machine working. Anyway, if you're thinking about a machine tool, these are a few thoughts I have on looking at them, inspecting them, considerations you have. I'm certainly not recommending machine tools or particular brands. I'm not an expert, but these are some of the things that I've picked up which may play into consideration in terms of what price you're prepared to pay and whether or not something's a good buy and so on. Now, before you even start looking at machines, there are there's probably more, but there are 4 questions that you probably need to think about. Firstly, what power have you got available? Have you got single phase or have you got 3-phase power? Larger machines usually need the 3-phase power. Some people say, oh, you can put a VFD on there. Well, you can, but you've got to remember that you can't get more power out of a VFD than you can put in. So if it's a small 3-phase motor, yes, you're okay, but if it's a large 3-phase motor, you may run into strife, getting sufficient power out of a VFD. There are other solutions. You can use rotary phase converters, but once again, similar thing, you can't get more power out than you can actually put in. Size of the machine, as in where are you going to put it? I had to turn down a very nice surface grinder a while back simply because I didn't have room to put it anywhere. But also, what size work are you going to do? If you want to do, I don't know, car parts or something like that, you might find a watchmaker's lathe is just way too small. Similarly, if you want to make watches and things, a lathe such as the one I've got is probably way too big for you. You need to think about what materials you're going to be cutting. Are you going to be doing relatively simple or easy materials to cut, like brass and plastics and things like that? Or are you going to want to get stuck into things like, alloy steels and titanium and that sort of thing, where you need a more rigid machine? And the last one I've got on my list here is, what are your expectations? If you're new to machining, you might find that your expectations are completely unrealistic. It does take a while to get proficient with using a machine, so you can produce decent surface finishes, two size, all that sort of thing, particularly on an older machine where there might be some wear to compensate. The next thing that you need to think about is the general condition of the machine. This isn't the sort of stuff which is necessarily going to say, no, do not buy that machine under any circumstances, but it's more along the lines of giving you a guide to how well has the machine been looked after, what's it been doing, where's it been. Some people say, oh no, you've got to buy a brand new machine because at least you know the history. Well, yes, you can argue that, but it's not necessarily the case. You can get quite reasonable machines second hand simply because the person who's owned them has decided they're getting too old, or they're moving, or they're doing something. They're buying a bigger machine. So there are good machines out there to be had, but you've just got to know what you're looking for. Number 1 on my list is lubrication. It's always nice to buy a machine where if you run your finger across, you can pick up some oil because it's lubricated. Similarly over there, right? The thing that kills machine tools is basically wear, and so provided the thing has been kept lubricated, you're a good way along to fixing things up. And as we say, You know, some lubrication is better than no lubrication. Another thing to look for if machines have got oil-filled gearboxes and things like that is the sight glasses. You can see here from the V shape, the oil's around about where it should be. The actual level in the glass doesn't worry me so much as the fact that there is oil there. If that was bone dry, one of the first things I'd be doing is, well, you know, thinking, has that been looked after? Has it been run dry or not? Some machines have things called one-shot oilers, mills and so on, and they've got a little T-handle you pull out, and if that's the case, then maybe you need to see is there any oil in that. Another trap are things like this. That's an oil port, and you take that out and you fill that with oil. But sometimes people get enthusiastic and they put grease in those. And so one of the things you need to check is that there's not lots of grease lying around, because some things can be greased, but things like this, you do need oil in there. This is the oil for the tailstock ways, and when I got it, I found a nice worn spot in a particular place because someone had put grease in there. Other thing you're looking for is rust. This is just a bit of scrap machinery that I had lying around the place, so it's as good as an example. And you can see a little bit of surface rust is just in there. That's not too bad, that'll clean up. But if you've got heavy rust on there, you've got pitting on there, you've really got to be asking yourself the question, what's this person been doing with this machine? Sometimes you get machines which are covered with oily dust. That's actually not so bad. That does protect the machines a bit, because you've got a layer of oil which is continually held in contact with the steel. If the dust, on the other hand, is, you know, the machines from a cement factory or something like that, where the dust could be highly alkaline or could be acidic, it may have attacked the metal. Paint is another thing you need to look for. I've painted this machine, so it's been perfect, of course, but sometimes you see pictures of machines where someone has gone and painted the ways, or they've painted some of the bits that should be left bright, or the screws or something like that. Now if you see that, it generally shows that the person who's done that doesn't understand what machine tools do, because, you know, if you've got two parts which are going to be in motion, you need to leave them bare. Look for broken parts. I'm lucky on this lathe that there wasn't too much that was badly broken, but this is one of the pieces where the little lugs here, there's a screw hole that goes through. You may just be able to see that's been broken off. Now in this case that's not major, because this part is for the taper turning attachment, and it's used, shall we say, gently. But if that crack was in the main housing, or was on one of the hold down lugs, you might be thinking, this machine could have been subjected to all sorts of abuse. This is the electrical cabinet of my mill. Now I'm not suggesting that anybody should be diving in here and having a look at some of these things, but it's worthwhile having a quick look in there if you can. Certainly don't play with these things unless you're a qualified electrician. Things you're looking for here are things like, you know, loose connections along there, fuses, what sort of fuses they take. One of the problems with some of these machines is the fuses are quite odd and hard to get, so you need to have a look, make sure everything looks neat and tidy, there aren't any scorch marks, that the connections look tight, and if there are things like fuses, the special types of fuses, then you need to have a look at those and make sure you can get them. It's probably one of the first things you'll notice, but something else to think about is the general condition and cleanliness of the lathe. If there are chips piled up everywhere, if there are, I don't know, you know, soft drink cans stuck in the chip tray or something like that, maybe the person using that machine hasn't been looking after it as well as they should have. I've seen machines where, and usually it's in companies where it's a general purpose machine, and so as a matter of fact no one looks after the machine. As I said, these aren't things that you can necessarily say don't buy it, but they're things that you need to take in mind when you're pricing these things. Once you've had a look at the machine, you then need to see what's not there. Most machines come with accessories. Now with lathes, if you're buying a new lathe, you'll generally get a 3-jaw chuck, a 4-jaw chuck, a faceplate, a travelling steady and a fixed steady. And there might be a few other bits and pieces like, you know, wrenches and things, oil cans for maintenance purposes, that sort of stuff. Mills usually don't come with that much in the way of equipment, or extra equipment. You might be lucky if you're buying a second-hand mill to get a vise with it. That's not necessarily always included, and you can buy vices as you can buy chucks and other things relatively easily through machinery dealers. They're regarded as something that wears out, that gets broken, that gets, needs to be replaced. Shapers, once again, you might get lucky and get a shaper vise. The difference between a shaper vise and a milling vise is just that a shaper vise, because of the reciprocating nature of the shaper, it's a bit more sturdy. It's usually got 4 hold down points instead of 2, a few things like that. If you can get one, that's great. If you can't, they're very hard to come by second hand, so you might be stuck with using a milling vise or having to clamp things to the table. Grinders are a particular one. Surface grinders usually have a magnetic chuck on them. If there's no magnetic chuck, you can expect to pay big money to get another magnetic chuck. And so the machine is comparatively, well, it's worth far less than it would be with a magnetic chuck on it. Things like tool and cutter grinders and cylindrical grinders usually come with a whole bunch of accessories, tail stocks and steadies and all sorts of bits and pieces. You need those. They're very hard to come by second hand. In fact, you bank on non-existent. So you need to make sure that if you're buying one of those machines, you've got all the bits and pieces that should come with it. One question you may have is, well, how do I know a machine is good or bad? That question was answered back in 1927 by George Schlesinger. This is considered the reference on this, and there are other standards around the place. If you pick up a copy of Connolly, it uses the same numbers. If you look in the Japanese standard, it uses the same numbers. So you'd say that George started everything. Basically, he put together a whole bunch of tests for machine tools. Most of them use something like a dial indicator and some various test bars and things like that. But for instance, this one here, checking the parallelism of the overarm with traverse movement. He's saying, okay, put an indicator there, wind it back. What's it doing? And then in the back half of the book, there are all sorts of limits. What's the permissible error? Now, these apply to industrial machines. The hobbyist machines, I've measured a couple. They don't come, well, the ones I measured didn't come in anywhere near this. And these things aren't easy to get to either. You've basically got to have a pretty good machine tool. But this was the acceptance standard. So if you bought back in 1950, you bought a machine and you said it was to Schlesinger standards, that was what you inspected against, and that was what the machine tool vendor said, yes, it's going to be good to that, and that's how it all worked. This is an example of how you might set up an indicator. This is a dial indicator. This particular device here is called a dial test indicator. They are slightly different. This works on a lever. These have got a plunger that goes in and out. But this is a test bar, and you could use a bit of ground bar, but the main thing is you need to know it's straight. And then by cranking the carriage along, you should get none or a very slight movement of the needle on the indicator. And that tells you that the ways here are either parallel to or slope gently away. The thing that you would worry about is if you had a sudden step, because that would mean that there's a patch of wear. As you can imagine, you can put the indicator on a test bar here, you can put it on the side, you could put the test bar, because it's got a Morse taper on it, into the tailstock. You can see what that's like. With the tailstock, you can put the indicator on the tailstock and then wind the tailstock in and out, leave the indicator stationary, or slide the tailstock along and see what the indicator does. Another test you can do is set up the indicator on the ways. Now, the carriage runs on the outside ways, the tailstock runs on the inside. So here I've actually got the tailstock way being indicated. And so if you would expect these to be parallel. Okay, so if I now crank that, and that's at 0.9, see how it's going down? That suggests that there's some relatively wear. And now, as I said earlier, and now it's back to steady again. Right? So just in here, there is a worn spot. When my tailstock comes up, it's effectively doing that. Okay, so something to watch for there. There are all sorts of things you can do, but what you're trying to do when you run over a machine with an indicator like this is just to try and get an idea of how worn is it, and is the wear even. Another thing to watch for is wear in screws and in gib strips. Now, this is the compound screw and nut. I replaced it some time ago because you can see there that there's a different width of the thread there than there is here. And if you watch carefully, you can see that there's that movement there. Now that's going to manifest itself as backlash, and that's bad. So once again, if you buy a machine which has got backlash in it, it's not the end of the world, but it may mean that you need to replace the nut and the screw. The other thing to watch for are the gibs. These are a dovetail arrangement on this particular lathe, and there's a screw to adjust them. Now, if you have a machine and it's nice and snug in the working section, you need to check and see what it's like at the ends of its travel, because as the machine wears, the middle section is probably going to wear more than the outside sections, and so that'll give you an idea as to how worn the machine is. In this particular case, I've actually scraped the gib strip, so it's flat, and scraped the slides, the dovetail, so it's flat. For those wondering about this backlash thing that I keep mentioning, this is the usual way you assess that. You put your indicator up against on a stationary member, and you try to see the relative movement. Now, I'm going to wind that in until that needle sits on 0. So is he missing it? Okay, now the dial on the machine now reads 38 thou. Okay, and the backlash is simply how much do I move that before the needle starts moving. There, okay. It moved a little bit before, but we'll call that, 83 thou. So maybe we'll call it 82 thou. Okay, so the backlash is basically the difference between 82 and 38, which is 45. So there's about a millimetre worth of backlash here. Now, you can work with that. That's not the end of the world, but it's always nicer if that number is smaller. This is one of those subjects where you could say lots and lots and lots and lots and lots about things, but I'll leave off now. A couple of passing thoughts though is that with machine tools, bearings are usually not cheap things if they're main spindle bearings. So do check that the bearings aren't worn. You know, if the spindle is in neutral or the gearbox is in neutral, does that spindle turn smoothly? If it feels a bit lumpy or tight or all that sort of thing, then you could have a bearing issue, which could get expensive. Rigidity is king with machine tools. The more rigid a machine is, the better off it'll be, because it won't chatter, it won't move and all that sort of thing as much. So if you have a choice between two and one is more rigid than the other, go for the more rigid. I say to people, you'll buy at least 2 machines if this machining bug bites. One to learn on, to see what you do and don't like, and then a second machine that will fix some of the shortcomings you've seen with other things, or try and sort out some of the issues that you have. You might decide after a while that you don't like machines with a particular style of control, and so you want to go to something else. Spare parts, please don't assume that any machine you buy you're going to be able to get spare parts for. It doesn't happen. If the machine is in current production, you might be lucky, but for the majority of machines, particularly import machines, or if the manufacturer has gone bust, you won't find spare parts. So don't expect that. If you do need spare parts for a machine, you either need to make them yourself or get someone to make them for you, and that's, I guess, the advantage of being in a hobbyist group or something like that, because there's usually someone who has been around for a while and knows how to make spare parts for things, or how to fix things, and all the rest of it. I hope this has been of interest to people, and if you've got any questions, or you have other tips and things, please post them in the comment section, so that other people can see them, and hopefully this is of use, and we'll see you for the next one.